In cryptography, a Caesar cipher, also known as Caesar's cipher, the shift cipher, Caesar's code, or Caesar shift, is one of the simplest and most widely known encryption techniques. It is a type of substitution cipher in which each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. For example, with a left shift of 3, D would be replaced by A, E would become B, and so on. The method is named after Julius Caesar, who used it in his private correspondence. A construction of 2 rotating disks with the Caesar cipher can be used to encrypt or decrypt the code. Caesar's cipher is a simple substitution based on the sliding of a single ordinary alphabet with fixed key. Once the equivalent of a letter is discovered, all the equivalent cipher letters are known. With the Alberti cipher disk, there are 2 mixed alphabets, and the key varies continuously during encryption. Therefore, the discovery of a single letter does not permit further progress. Frequency analysis is also impossible because the same letter is always enciphered differently. The Vigenère cipher is based on a single, ordinary alphabet like that of Caesar, and is easily solved after discovering its fixed period by means of the cacique exam. This is not possible with Alberti. The Alberti cipher disk, also called formula, is a cipher disk which was described by Leon Battista Alberti in his treatise De Cifris of 1467. The device embodies the first example of a polyalphabetic substitution with mixed alphabets and variable period, and is made up of 2 concentric disks. The larger one is called stabilis, stationary or fixed. The smaller one is called mobilis, movable. The circumference of each disk is divided into 24 equal cells. The outer ring contains 1 uppercase alphabet for plain text, and the inner ring has a lowercase mixed alphabet for ciphertext. The outer ring also includes the numbers 1 to 4 for the super-encipherment of a codebook containing 336 phrases with assigned numerical values. In cryptography, the tabula recta is a square table of alphabets, each row of which is made by shifting the previous one to the left. The term was invented by the German author and monk Johann Trithemius in 1508 and used in his book Polygraphia, which is credited with being the first published book on cryptology. Trithemius used the tabula recta to define a polyalphabetic cipher, which was equivalent to Leon Battista Alberti's cipher disk, except that the alphabets are not mixed. The tabula recta is often referred to in discussing pre-computer ciphers, including the Vigenère cipher and Blaise de Vigenère's less well-known AutoKey cipher. All polyalphabetic ciphers based on Caesar ciphers can be described in terms of the tabula recta. It uses a letter square with the 26 letters of the alphabet following 26 rows of additional letters, each shifted once to the left. This creates 26 different Caesar ciphers. This method removes the letter frequencies from the ciphertext, making it appear as a random string or block of data. However, if a person is aware that this method is being used, it becomes easy to break. The cipher is vulnerable to attack because it lacks a key, which is said to break Kirchhoff's principle, a rule of cryptology. In 1550, Girolamo Cardano, 1501 to 1576, known in French as Jérôme Cardin, proposed a simple grid for writing hidden messages. He intended to cloak his messages inside an ordinary letter, so that the whole would not appear to be a cipher at all. Such a disguised message is considered to be an example of steganography, which is a sub-branch of general cryptography. But the name Cardon was applied to grills that may not have been Cardon's invention, and so Cardon is a generic name for cardboard grill ciphers. In cryptography, a one-time pad, OTP, is an encryption technique that cannot be cracked if used correctly. In this technique, a plain text is paired with a random secret key or pad. Then each bit or character of the plain text is encrypted by combining it with the corresponding bit or character from the pad using modular addition. If the key is truly random, is at least as long as the plain text, is never refused in whole or in part, and is kept completely secret, then the resulting ciphertext will be impossible to decrypt or break.